Hello, everyone. I've got my chat pulled up this time, so it'll be easy and I don't have to wait too terribly long on individuals. Let me verify we are live everywhere. Let's see. I'm going to just double check. We have somebody on there. All right. Let me check out Periscope. Make sure we're there. I know we're live on Facebook. Hello, Facebookers. And yep, there we are. We're on Periscope. You see me. Hello, Comet Girl. Yes. So let me make sure we're live on YouTube. I think we are. So, yes, we're live on YouTube. Hello. Hello. Is it Nether6? And Bo is on Rasmussen or Rasmussen. Hello, everyone. So, if you're new to this type of show, what I essentially do, yes, you're in time. We are going to talk about the lightning. Okay, so that was the topic that was voted on by all the viewers, and so I posted polls on Google Plus. I posted polls on Twitter, to where the majority of people who watch my show are. I posted polls there to give them a list of 4 different topics, and this is what everybody chose across the board, actually, on Google Plus and on Twitter. So every week, I usually, you voted for lightning. Yay, Comet Girl, you won. Hello, Tom. Hello, David. Hello, everyone. So what I do is I post a poll every week, and the audience picks what it is that I talk about. In previous episodes, I had gone back over older episodes in the new format, this format. And so the more popular episodes I went back over and redid in this format. So it's Rasmussen. Okay, Bo, it's Rasmussen. I got it. And so today we are going to talk about the science of lightning and all of the different things associated with it, what all of these little finger-like things are called, that sort of thing. And we're also going to talk a little bit about ball lightning. Ball lightning is pretty cool. So let's go ahead and get started. So today we are talking about this thing known as lightning. Woohoo! It's pretty exciting stuff. So what is this lightning stuff? What is it? That's what we're going to talk about. What it is, how it does its thing. Oh, you like my theme music. It's cool. That was the graphics and everything was by Gonna Go For It, aka Peter. He makes my intros and my outros, so that's really nice of him. So I'm glad you like it. So lightning, we're going to talk about what it is, how it works, and all of the stats associated with it. Hello. So if you have questions, you can ask me as we're going through. And if I don't have the answer right away, that's all right. You know what? I can totally get you that answer later. And if you have questions and you're watching after we've already streamed live, just post your questions in the comments, and that's okay. And I will get back to your questions ASAP. Yeah, lightning is pretty cool. So we're going to talk a bit about all of this different stuff. Good morning. So what is lightning? Well, it's generated from what we call a potential difference between charges. Now, it also often comes from cumulonimbus clouds, also known as CB clouds. Happy Saturday, Don. Hello. And the stronger the field, the more likely for ground strikes. So what is this that we're talking about in regards to potential difference? Well, in the initial stages, what we have here is the development of air. Air usually acts as what we call an insulator. Now, once that difference starts to increase between these positive and negative charges that are dividing up like this, they're spreading out. We have the more negative charges are moving towards the bottom of the cloud, and the more positive charges are moving towards the top of the cloud. So these positive and negative charges that are moving between the cloud and the ground, when these differences become so strong and these charges become too great, that air that we see as an insulating capacity, that particular capacity that air has as an insulator, breaks down. And then there is this rapid discharge of electricity that we know as lightning. Am I ready for tomorrow, Stephen? Isn't that Sunday? Sunday is tomorrow. Sunday's tomorrow. I'm ready for Sunday. I'm still going to be on SciStrike, right, with the climate change talk. So air normally is an insulator, but in this case, when that potential difference between the two becomes so great, it goes boom, and we end up with a breakdown of that air that's usually an insulator, and therefore we get lightning. I'm always ready for Sunday. So what can happen? Well, what we have is we can have stuff, we can have intra-cloud lightning. We can have lightning that's among the clouds. That's usually the most common. And then we can have cloud to ground lightning. Now, lightning can occur between these opposite charges that we have in between these clouds. That's the intra-cloud lightning where we see it lighting up and stuff. Or between positive charges in the cloud and on the ground. Cloud to ground lightning. Now, cloud to ground lightning is divided into two different types of flashes depending on the charge in the cloud and where the lightning originates. So if you've not been to the NOAA website, NOAA, they have really cool graphics in regards to cloud and lightning formation, and it kind of breaks it down a bit, which is kind of easier to kind of digest. Now, I do have at the end of this slide show, whatever, there's always my sources, and if you want access to my sources, I post all of my slides for all my webcasts on scientistmel.com, to where you can download the slides yourself and go and dig into all of my sources and just have some fun with lightning, right? So, what we got here. So how does this lightning thing happen? What's going on with this? Well, normally the Earth is negatively charged. That's what normally the Earth is. We got a negative charge going on. Now below a negatively electrostatic induction, that's this big white fluffy cloud here, it creates a section of positive charge on Earth, all right? So between the cloud and the Earth, what we have is this huge capacitor. Now, as I mentioned before, the potential difference between charges becomes so great that there is this domino effect of breakdown within the cloud. So we have electrons that are jumping among the air as this insulator, this air insulator breaks down, now aids this potential difference between the positive and the negative charges. So the air is kind of helping out these charges at this point. Once it becomes way over, just, yes, gonna go for it. Does really cool stuff. You can go check out his website, and he actually does make, like I said, all of my intros and outros. He's a pretty cool dude in that regard. Okay, so now what we have is something called the leader. Now the leader is that initial charge, that initial strike that comes out. It's a bit erratic, and it doesn't really have a potential target just yet. It isn't really attracted to anything outside of the overall positive charge on the ground. Now, once it reaches a close proximity to the ground, what they call a step or two, the electric field undergoes an immense amount of stress. Any objects on the ground at this point that potentially disrupt this field becomes a target. This is people, buildings, trees, all of these. They can emit what we call a positively charged streamer. Okay, so streamers have are basically emitting this positive charge. Now this connection can happen and do what we call a return stroke, and that's observed as the charge moves back up that ionized channel, returning to the cloud. Now a peak current for a return stroke can be over 100,000 amperes. So so here in these little particular images I have from NOAA, once again from NOAA, we have the initial leader, and then we have what's called a dart leader. Then you can have other little dart leaders kind of come back out, and I'm going to show you another really cool example of that. And that's where they kind of branch off from each other, are those dart leaders, and the return stroke goes back up. Now this return stroke may not discharge that cloud completely. Therefore, other dart leaders can cause a flickering effect. Oh, I just answered what you were about to ask. Yay! I'm so glad, Lavender Lady. You once had a lightning strike the house you were walking by. It took you a second to figure out what had happened. The flash of light and then the sound of thunder was unbelievable. It's pretty scary, isn't it? So here in this particular image, we have an example of the initial leader, and then it breaks off into other darts. Now, it does hit the ground at one point, but as I said, that return stroke back to the cloud may not discharge all of that, may not cause a total discharge, emptying out the cloud, so you could have those little fingerlings, those other little dart leaders, come off. Now, who's ready to talk about ball lightning? Somebody had asked me to cover this in this particular broadcast as I was going through. It's also known as St. Elmo's fire. Ball lightning's kind of cool in that it's that floating fireball type of thing that we see or we hear about on airplanes that kind of coast through, and you're like, what the heck is this? So there's a CSIRO scientist named John, it might be John Locke, or I would like to say Loki because we've been doing Thor earlier. Nether, it literally shook you to the core. You felt the thunder more than you heard it and didn't hear much for a time after. Yeah, that's pretty scary. Lightning is a very scary thing, and it's exceedingly powerful, and I'll talk about some of the statistics in regards to it here in just a bit. Now, John Locke is a CSIRO scientist. It might be Loki, and I kind of wish it was Loki because that would just be cool because we're talking about Thor. Earlier, I had little images of Thor. He has developed a new theory focusing on how ball lightning occurs in houses and planes. So remember, ball lightning is this heated looking orb that's kind of like a fireball that can kind of move, and it can pass through glass, and you're like, what is this witchcraft, this strange phenomenon? Well, not only is he looking at how ball lightning occurs in houses and planes, but he also looks at how it can pass through glass. So his particular theory suggests that ball lightning is caused when you have leftover ions that move and are kind of go whoosh to the ground after lightning strikes. Now, they tend to be pretty dense. Now, he says a crucial proof of any theory of ball lightning would be if the theory could be used to make ball lightning. Now, this is the first paper which gives a mathematical solution explaining the birth or initiation of ball lightning. So this particular fella has taken mathematics and has been able to generate a particular proof to show how ball lightning goes. Yes, ball lightning is St. Elmo's fire. I'm not certain, phenomenon off a ship's mast. If it has something to do with lightning, then it would be. You can almost understand why the Vikings thought Thor was responsible. To a degree, yeah. So, St. Elmo's fire. All right, so Loki or Loke, I don't know how to say his last name, and that is entirely my fault. I'm terrible with last names. So Loki suggests ball lightning happens in homes and airplanes when we have this stream of ions that kind of grow and develop on the outside of a glass window. The result is an electric field on the other side exciting those molecules to form this ball discharge. So it seems like it's passing through glass, but what he suggests is that that particular growth of ions outside of the glass is affecting the air on the inside, on the other side, and this causes those particular molecules to form that ball. Now this particular ball discharge has a driving electric field of about 1,000,000 volts. So ball lightning isn't something to just, kind of toss aside, and it's still very, very elusive to scientists as to how exactly it happens, but now we have math that can kind of help us figure it out in regard to what causes it. So, a little bit more I want to talk about. Loki continues saying, okay, so this is part of his paper too. Other theories have suggested ball lightning is created by slowly burning particles of silicon formed in a lightning strike. But this is flawed. One of the ball lightning observations cited in this paper occurred when there was no thunderstorm and was driven by ions from the aircraft radar operated at maximum power during a dense fog. So Loki actually talked to eyewitnesses that were in the Air Force that have had this phenomenon happen where there was no particular lightning storms going on. His paper is the first to present a mathematical solution explaining the occurrence of ball lightning using standard equations for the movement of electrons and ions. Now, he also says that this paper is unique because it not only explains the formation of ball lightning, it can also explain how it's able to pass through glass. So this is pretty amazing. Ball lightning is pretty freaking cool. And we're still learning so much about it. So if you haven't checked out Loki's paper, please feel free to do that. And I do have a link to that information at the end of this particular talk, and you can find all of my slides on my website. So now I want to show you a really cool website you can go to. It's called lightningmaps.org. If you haven't been to lightningmaps.org, you totally should. Let me see if I can pull it up, and I'll pop it over here so you can have current lightning strikes. But that was a screenshot that I took earlier. But screenshots aren't the same as the real thing, are they? So I'm going to carry this little bugger over here. So here is, through the amazing technology of science, we have this here. All right, so we can actually go in and have a look. And you can see, and you can zoom in or zoom out, and I apologize, but it seems like my bandwidth is a bit slow. But you can go in, zoom out. If you want to look more. Here we go. So we got some action. Ooh, we got too close. Let me zoom out. It's a 54-minute delay is what it says. Oh no, 141 per minute. Delay is 1.3 seconds. So here we got some lightning strikes happening. The top of Africa, off the coast of Australia. We got some going on in the US, right around the lower region. So it's pretty interesting. You can see the actual activity regarding lightning strikes. And also, for those of you on Facebook, if you have questions, please drop them into the comments. So that's lightningmaps.org. Please do check out that really, really, really cool website and have a look to see what's going on with lightning. You saw ball lightning once. Has Loki been able to reproduce the effect under laboratory conditions? I'm not entirely certain. I can send you the link. I think there was a group of individuals that were using his particular mathematical equations to try to replicate those. I know Tesla's been able to, I believe Tesla was trying to do the same type of experiments to replicate ball lightning in the lab. And I think using what Tesla was doing, and possibly along with these particular mathematical equations, they might have been able to. I'm not 100% sure, but I have links and you can dig down a bit deeper and see what all they've managed to discover. So that's kind of exciting. That was a new thing that I just found out about today with the ball lightning. So let's talk a little bit about lightning stats. The cloud to ground are common. So as I kind of shown you a little bit, cloud to ground, what happened to my thing? Sorry. Yay! Cloud to ground are common. So approximately 100 every second can contain about approximately 1 billion volts of electricity. It can travel to the ground at about 200,000 miles per hour. Now, each segment that we see in those particular darts that come off, or even as the leader, can be around 150 feet, also 46 meters long. Return strikes, so if it hits something and it goes back up to the cloud, that can travel as much as 200 million miles per hour. For a near real-time, less than 1 second lightning map, you can also go to blitzortung, blitzortung.org. Okay, it's a volunteer-based site. That's pretty cool. All right, so most lightning never leaves the clouds and can travel between them. So we know that we have a lot of intra-cloud type of activity. There are some rare forms that are caused by extreme forest fires, snowstorms, and even volcanic eruptions. Now, in the U.S. alone, lightning kills about 100 people each year. However, in 2017, only 16 people were killed by lightning. That's a new record low. Who knows why? It just happens to be a thing. FEMA estimates the odds of being struck by lightning are 1 in 600,000. Florida has an unusually high rate of lightning strikes at about 1.4 million flashes per year. Now that's not actual strikes, that's flashes. And New England has only a few, while California has about 85,000 strikes per year. Now here's a little bit of interesting trivia. There's a tiny Central African village called Kifuka, and if I say that wrong, I am very sorry. I say words wrong sometimes. Now, this particular village is hit by lightning strikes about 158 times per year. No other region or town or anything in the world has as many strikes. So that's kind of interesting, huh? So let's have a look. Your area, in my area, made storms 2 days ago. Wow, it's crazy. So let's talk a little bit about what do you do if you are in a particular storm. What do you do? What goes on? How are you going to handle this? Faraday cages. Faraday cages are so much fun. Essentially what happens is, if you're in a lightning storm, you want to go to your car. Your car is going to be amazing at protecting you from lightning. Now, the steel frame of this particular hard-top vehicle can protect you from the lightning, not the tires. Okay, rubber is not an insulator. There are farmers who are riding tractors with rubber tires and they will still get hit by lightning. Yes, do not try to replicate Ben Franklin's experiment. Don't do it. So this steel frame protects you, not the rubber and the tires. if you are not touching the metal. So rush to your car, don't touch the metal. The lightning charge travels to around the outside the vehicle. All right, and this creates what we call a partial Faraday cage, and it protects the occupant inside of it. All right. So the lightning will kind of be carried all the way around through the outside of the vehicle, and you and your loved ones, your pets, whoever's with you, is in the car safe as long as you don't touch anything metal. You will be fine. And don't play golf. Oh my goodness. This, people who emit positive charges on, positivity, they're like, emit positivity, be positive on, spread positivity, not during a thunderstorm or lightning storm. You don't want to be positive in a lightning storm. That increases your risk of getting struck. That's not cool. That's not cool. You don't want to be positive for that. So that's what I've got in regards to lightning. It's generated from potential differences, different types of lighting. We have intra-cloud lightning. We have cloud-to-ground lighting. We have our leader that just kind of goes, and then you have darts that come off of it. You have ball lightning. That's crazy type of lightning that just kind of forms. We think primarily after lightning strikes, but we're finding mathematical models that kind of can explain how it is it can even pass through glass. John Loke, or Loke, L-O-W-K-E. We've talked about statistics and what to do. I've experienced a lightning strike 40 to 50 meters from where I was standing a few years ago. I started feeling a strange tingling sensation, and I screamed like a little girl. You know what? Little girls can scream properly. Everybody should scream like a little girl. They do it right. Here are my sources, but I know you can't read that. National Geographic, physics.org. I've said NOAA a lot, N-O-A-A. Electricmuseum.com is pretty cool. Lightningmaps.org. Yeah, lightningsafety.noaa. They have a lot of stuff there. phys.org. So phys.org. That's another particular source that you can go to. So all of these particular sources are pretty cool. But like I said, I don't expect you to be able to read all that. That's why I put all of my slides on my website, scientistmel.com. Hello, anti-ordinary. So I'm going to take a moment to thank my patrons who make all of this possible. If you like what I do, I do all of this primarily myself. I have a couple people who do help me out from time to time and do things for me. I have some people that help me with my Facebook page. Darnex71, shout out to you. So I want to take a moment to thank my patrons: Tony, James, Lauren, Jen, Carl, Melanie, Patrick, Daniel, Paula, Tim, Carrie, Cersei, Keith, Zachary, Tony, Graham, Tristan, Jennifer, Corey, and Heavy. You guys help me keep the lights on. I've been able to get better lighting. I've been able to get a website. I've been able to get a lot of things that help me up the quality of what I do. And now I'm branching into more shows and making science more accessible for individuals. And I'm hoping to start actually going and visiting various towns and give in-person talks. So if you like what I do, buy me a coffee every month. It starts at $1 a month, and I do have an audio podcast called Hey Scientist Mel. It's hashtag Hey Scientist Mel, to where you can take me along with you and hear me talk about various things in regarding science. And I have guests on as well. So these are all things that I do for you guys. Hello. I'm so glad you guys are here. So where can you find me? Just everywhere. Google Scientist Mel, and you'll find my website, my Patreon, Periscope, YouTube, Facebook. I'm all over the place, and I'm here to try to help you answer your questions and direct you to reputable sources and give you a little bit of fun. ASIM.DK. So I'm trying. I have to look up asim.dk. I think you sent that to me, but I haven't had a chance to investigate it furtherly. Further, I said furtherly. I made up a new word, guys. Furtherly. Thanks for hopping aboard here. I will be on SciStrike tomorrow to continue on their climate change series. I am all over the place. I hop on various channels and input a bit of science, and you can check me out most recently on Paulogia's channel, where he actually animated me talking about science with him, and I bust through the wall and everything. It's kind of neat. So Paulogia, Paulogia, check him out. I am in many live streams. I am. Being electrocuted is a fun feeling. Probably not with the extensive amount of electricity associated with lightning, though. I do not recommend getting struck by lightning. It's not a lot of fun. Oh, and hello to everybody who popped on Facebook. I see you, Major. I see you, Monty. I don't get to pop onto Facebook as much as I do on my Restream chat, but if you do have questions and you're on Facebook, pop them onto here and I can answer them for you. And hopefully I'll be able to make more seamless integration in between the Facebook comments along with the Periscope and the YouTube comments, because they're kind of mushed together. I did break Paul's backdrop. You know, I was out busting baddies over like the bad science on Paulogia's channel, and you know, what can you do? What can you do? You gotta bust the bad science. Somebody has to. And if you like reading, you can check out scientistmail.com. I regularly put articles there. One of my more popular ones most recently is where I tear apart bad science that PETA uses to push their agenda. And PETA's blocked me on Twitter. So I suppose that should be a badge of honor. Mel, what is space-time made of? They don't know. We're not entirely certain. We think it's a fabric. A Danish sensor that was just activated on the ISS a few days ago. It's looking for high altitude lightning strikes. Oh, so that's the SKIM. That's what you're talking about. Well, that sounds pretty cool. I like that. Does anybody have any questions about lightning or anything like that? If not, you know, we can chat for a little bit. I don't have a lot that I have to do today, but I do want to try to get some of my Scientist Mail shorts made. So if you're not a fan of the live streams so much, fear not. I will be taking all of my previous Science of shows, since I still have all the material. I'm going to condense them down into about 10-15 minute shows called Scientist Mail Shorts. So if you don't like the long drawn out live streams, that's okay. I will have the shorter version. So could we use lightning as a file source? I don't know about a file source, man. I would say it's probably not really a viable source of energy too much. I wouldn't think. It's a bit uncontrolled in its movement of a current that's just gravitating towards the highest amount of positive charge. And if you happen to be emitting a higher amount of positive charge in a bit, that's why you don't want to be in an open field, because you're closer to the cloud for the ionized channel. Oh, where's the best place to hide from lightning? Under a tree or in an open field? Man, I don't know if you want to be under a tree, because if it gets like zapped with lightning, then it's going to catch fire. If you're in an open field, I would say try to find a hole, if there's like a concave space, and lay flat. Just lay flat. You don't want to be a beacon. I did talk about ball lightning. I did. And I talked about recent math that's trying to explain why it passes through gas. So that's pretty cool. Ball lightning's kind of neat. I did. And see, the thing is some people are like, I missed the stuff that we talked about earlier. you know, that's okay. My streams are up forever. I keep them up on Periscope. I keep them up on YouTube. They're not going anywhere. So I do keep them up forever. You don't have to worry about it. And if you don't want to go through the entire stream, I am going back steadily and recording shorter versions for you to check out later. That will be called Scientist Mel Shorts. So if you're on YouTube, you'll be able to go and find the playlist for Scientist Mel Shorts. Click on that and all of them will be there. If you like the live streams, the Science of playlist is the one to click on. If you like just tiny short videos, I have bite-sized videos, and then I also have my minute cognitive bias. Oh, thank you, Daniel. I'm glad you enjoyed this. So I have my entire cognitive bias series. I'm still making videos for that. Those are my 1 minute little bite-sized videos talking about cognitive bias. So energy source. Yes, and possibly for lightning, but it's kind of erratic and it's kind of hard to predict unless you have like a highly positively charged source to where it can zap it, you know. Hello, Michael. Hello. So we've talked about lightning today. So this has been pretty awesome. I'm glad you guys are here. I'm glad you guys are here, and I'm super excited that you guys get to spend every Saturday with me talking about a various science things. So that's pretty groovy. So check me out on Twitter, check me out on Google+. I'm also on Facebook, and I have my own website. And if you get confused, where do I find her? Scientistmel.com. Just go there, and all of my stuff is there, and you can find where all else I am on that particular website. What upcoming live streams am I doing? Well, I'm on SciStrike's channel tomorrow talking about climate change. I'll be back here next Saturday with whatever topic it is that you guys vote for. This week it was lightning. Last week it was thermodynamics. This week, who knows? I'll post various topic suggestions that I get from you guys into a poll, and people go through and vote. It was pretty close between allergies and lightning this year. So allergies will probably, this year, this week. So allergies will carry over to the next poll. And then I'll toss in a new one. Go on, amino. You want to talk about amino acids? Hello. Thank you, Ms. D. Thank you so much. So, all right. So if you haven't subscribed to me on YouTube, please do. I still have to have 4,000 hours of viewing before they let you get monetized to try to help boost your work. So I'm about a fourth of the way there. Got almost 1,000 hours of viewing from people. I need 3,120 more before they'll let me monetize. I haven't done the science of antimatter. Go watch Lost in Space. Okay, Comet Girl, enjoy it. I will say I had a hard time a little bit with it but that's only because I knew a lot of things they were saying was wrong. But that's all right. It seems pretty cool for the most part for people who enjoy that. It's hard for me to separate. Sometimes I can't separate the science from the sci-fi. So, but thanks for stopping by, Comet Girl. I will add the science of antimatter. We'll toss that in there too. The autism spectrum has to be one of my more popular ones, especially in regards to how to navigate the education system. It's 4,000 hours. It's 1,000 subscribers and 4,000 hours of viewing. They decided to do that at the end of February. 1,000 followers and 4,000. It's not views, it's hours. They've changed it to 4,000 hours, not 4,000 views. So YouTube is getting increasingly more difficult in order to become monetized, and it has to be over the past 12 months. And so I've only gotten 982, but I haven't been so heavily active in YouTube until the past few months, and so that's part of it. But they did just change the rules again in February. So the end of February, they made brand new rules. So yes. So, you know, that just means I have to make more stuff. Oh, thank you, Michael, for subscribing and liking my videos. I'm trying. We're trying to do the best we can to get good information out there to kind of counter all the wrong information that's going around. But hopefully this will help. And I'm glad you guys are enjoying it. That's what's important, you know? That's what's important. Sharing the love, sharing the science, and spreading the knowledge. Does anyone know why Hollywood keeps getting science wrong, especially if genetics is brought up? There are particular shows that have science contractor type of people that sit there, and science analysts that go through that. That is an entire job. Thank you, Nether. That is an entire job just for that. So, and Battlestar Galactica is one of those shows that had a science analyst on set. You have to watch Scientists Mel 4 hours a month. Okay, okay. Isn't Maia's Dragon? I'm not certain how to say that, but thank you. It's good science. So it's hard. You know, it is hard because you have to make it, you have to be able to suspend some suspend some reality in order to enjoy a film. Otherwise, Star Wars, it's just miserable unless you think, okay, their physics doesn't work the way ours does. So you have to suspend disbelief and suspend what your thoughts of reality are in order to fully engage in that. But that's still fun. You just got up. Oh my goodness. But I'm super glad you guys are here, and I'm really glad that, you know, we get to have every Saturday and do this. I do intend to keep it at 10 a.m. every Saturday morning, which means I get up super freaking early, and I do. I wake up about 6 o'clock in the morning and start working just on my Saturday show because I have a day job. I have to still work. This would be awesome if this was my job, but that's not the way the world works. But I still like my job too, so I enjoy that. But I spend a lot of my off time, just working on this project because it's important to me. I want to promote scientific literacy. I want to help people understand what the science is and to be curious and enjoy it and just roar, you know? 29 hours to go. Woohoo! Yes, iStrike's Sunday live stream is at 5 p.m. Eastern. Is it Science Sunday live stream 5 p.m.? Is that Eastern or Central? Oh my goodness. It's 1 and 1:48. All right. Well, I guess I'm going to hop off of here. It's been really, really awesome and lovely hanging out with you guys. You guys rock. Uh-oh, power is flaring. You guys rock. And so if, you know, you can always contribute. If you can't contribute monetarily, spread the word. Help me get views in. Help me reach my goal of trying to get to where I can go and talk to people and engage with them. So that would be fantastic. And thank you for being here. Look to my website, scientistmel.com. You can find all my information there. And I'll have my peer-reviewed paper coming out soon. Woohoo! On my breast cancer test. I'm excited. And thanks for being here. You guys have a super awesome Saturday, and I will see you tomorrow on SciStrike's channel. I might hop back on here tonight and have a impromptu Google Hangout. I'm not certain, but we'll see. But you guys have a fab day, and I'll talk to you later. Squishy science hugs.